I was a little surprised to see some factoring polynomial questions on some of the practice exams I looked at. It's kind of an obscure topic, but we're going to cover it here. It takes a little background to properly, even broach the subject, but let's do it here, and we'll cover a few things. When you're factoring a polynomial, step number one is we're going to look for what's called the greatest common factor. Okay, greatest common factor. Factors are smaller things we can multiply together to make a bigger thing. So let's just say I've got an 8x squared and a 12x to the third. And I wanted to find something common, the greatest common thing between these two things. Well, I've got an 8 and a 12, the coefficients. I know the 8's got 2's inside it, it's got a 4 inside it, right? The 12's got a 4's and 3's and 6, depending on how you look at it. But what's the greatest common piece? Well, the greatest common piece between an 8 and a 12 would be a 4, right? I could extract a 4 out of the 8, and I can extract a 4 out of the 12. Okay, so I'm going to do that. I'm going to write the 4 here. And then I'm going to look at my x terms. I'm going to say, well, this guy can give me a full x squared. This guy can give me a full x cubed. But I need to know what's common. Well, the greatest common. Since this one can only give me an x squared, I can't take more than an x squared out of that one. So I'm going to pull an x squared out of both of these pieces too. And I'm going to call 4x squared my greatest common factor. Okay, in other words, let's pretend this was some kind of polynomial added together here. Okay, I've got 8x squared plus 12x cubed. Pardon me, this is cubed. I can't combine them. They're not like terms. They're just sitting there doing nothing. But I can say, you know what? I'm going to undistribute. I'm going to extract out of there. Now I'm doing the reverse process of distributing. I'm going to take a 4x squared and I'm going to pull it out of both of those. So I'm going to take that 4x squared and yank it out of there. And now I got to ask myself, what would be left over? Well, if I have an 8x squared and I'm going to pull a 4x squared out of there, the only thing left is going to be a 2, right? Because if I redistribute it, I'm going to get 8x squared again. And if I ask myself the same question over here, I'm going to have a 3x left. Because if I redistribute, I'm going to have a 12x cubed. Okay? And how I know I got the greatest, I really got the greatest common factor is that there's nothing common left here anymore, right? If I look at a 2 and a 3x, there's nothing in common whatsoever. Okay, so I know I got the greatest common factor and I extracted it out of there. Okay, so that's kind of our first little job with factoring is find what's common and extract it away. So let's say I've got a 5x squared, plus 30, let's say. Now I don't even have any x's over here. So I'm going to say, aha, I know there's a 5 hidden in my 30. So I'll factor out a 5, and I'll have an x squared plus 6 left over, right? So I distribute, I get 5x squared plus 30. We are undistributing here. That's what we're doing. Let's try 18x cubed plus 27x squared. Well, between an 18 and a 27, you got to think about it. What's the biggest common factor hidden inside an 18 and a 27? It would be a 9, right? And when it comes to these exponents, the smallest exponent is actually the greatest common factor. That almost sounds like I'm contradicting myself. The smallest exponent is the greatest common piece. In other words, I only have an x squared here. This guy could give me more, but this one can't. So the smallest exponent of 2 is the greatest that can come out. So I'm going to factor out a 9x squared, and I'm going to ask myself what's going to be left over. Well, that'll be a 2x there, because when I remultiply it, I'm going to get an 18x cubed. And here it's just going to be a 3, because when I remultiply it, I'm going to get a 27x squared. Okay? Greatest common factor. Let's try another. Yeah, let me recycle a couple. I'm trying not to recycle these pages because you can see through it, but I'm going to run out of paper here pretty soon. I got to get a new stash. I've got 3 pieces. Okay. Between a 16, a 12, and a 4, what's going to be common? A 4, right? There's obviously a 4 inside of a 4. There's a 4 inside of a 12 and a 4 inside of a 16. Got it. What's my smallest exponent here? X cubed. If I extract that away, watch out now at the end here. I'll have a 4x squared, right? Because if I remultiply it, I get 16x to the 5th minus a 3x. Because if I remultiply it, I'll get negative 12x to the 4. And now don't forget about this. Plus 1. Because if I remultiply it, 4x cubed times 1 gives me 4x cubed. Factoring is just showing something in a different form. Okay, no different than if I said 8 can be thought of as 4 times 2. It's still an 8. Well, this can be thought of as that times that. Okay? We're showing it in a different form. By factoring out what we would call the greatest common factor. Okay? Sometimes the greatest common factor is a multiple piece entity. In other words, x squared times x plus 3 plus 5 times x plus 3. You see, the only thing common here is the x plus 3. Okay, so that's going to be factored out. Okay, let me make it even simpler. What if we had x squared times, a plus 5 times a? And we wanted to say what's common between these two things. Well, the a's are common, I see that, and then the only thing left to compare is an x squared and a 5, and clearly there's nothing common there. So I could extract away the a, unfactor it out, undistribute it out of there, and the only thing that would be left would be x squared plus 5. Okay? That a can be anything. Okay? I could have x squared times, blah, 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 plus 5 times that same blah, blah, blah. Okay? My blah, blah, blah is common. Out it goes. What's left? X squared plus 5. Okay, so sometimes my greatest common factor is a polynomial. It doesn't have to be a monomial. Okay, we can still factor it out. Okay? Okay, I'm just debating on how far to go with this factoring business. I don't want to go too far because I know you don't have that many questions on it. Let me just go a little bit more. Alright. If I have something that appears that I don't have any factors. Look at this one. X cubed plus 4x squared plus 3x plus 12. I've got 4 terms there. There's not a common factor in there, right? I mean, these all have an x, but 12 doesn't. And there's no coefficient that's common. There's nothing common to all 4 of those pieces. So it almost seems like I can't factor it. But when I have 4 pieces and this happens, I'm going to try to group them together like this. Group and group. Okay, well now I'll just look at the first group. What's common between an x cubed and a 4x squared? Well, there's an x squared in both of those, right? If I factor out an x squared, I'm going to have an x plus 4 left over. You see that? Over here, so I got a plus sign now. Over here, what's common? Well, I got a 3x and I've got a 12, so a 3 would be common. So I'm going to factor out a 3, and what would be left? An x plus 4, and oh, what do you know? Now I've got matching x plus 4s. That can come out. X squared plus 3. Okay? I extract away the x squared plus 4, just undistributed out of there. The only thing left is x squared plus 3. Okay, that's called factor by grouping. Okay? Again, I know factoring is going to be limited on your exam, but I also know well, on the practice exams, I should say, on some of the practice exams, one of these problems comes up, and this is why I even go down this road of factoring. It's a special factor. If I have an a squared minus a b squared, we saw this backwards a little while ago in another video, I can say, aha, that equals a plus b times a minus b. Okay, you really kind of need to commit that to memory. I don't know how else to say it. Okay, we got to spot the pattern. It's not always obvious, like this one. X squared minus 4, if you're asked to factor that. You say, that's not an a squared minus a b squared, but yeah, it really is. Because that's an x squared, and what is 4? 4 is 2 squared. So see how it just fits that pattern perfectly. So that's going to be x plus 2 times x minus 2. Okay, and if we did the FOIL process and we expanded this back out the other way, we're going to get x squared minus 4. Okay, this is now going in the reverse order. We'll call that factoring. Okay, it takes a little practice to spot, to see that you really have that pattern. What about this one? 81x squared minus 49. Now this one doesn't look at all like it fits that pattern, but let's think about it. 81 is really 9 squared, right? So I could really call this 9x, everybody squared, right? Because that would be 81x squared minus 7 squared. So yeah, I've got it. That's really an a squared minus a b squared. What are the factors? They are immediately a plus b times a minus b. So let's do it. So a in this case is 9x plus b is 7 times 9x minus 7. I can immediately write those factors, okay? Okay. Boy, oh boy, oh boy. I don't think they're going to beat you up too bad on it. I really don't. They shouldn't. Shame on them if they do. Occasionally, I mean, I like to throw this in the old algebra class here. This one here. Do I like to, I mean, I like to do it. Do I want to do it? I'm not going to do it. Forget it. Let's just practice a couple more. How about this one? 9 minus 16x to the power of 10. Oh boy, now this really doesn't look like it fits the pattern. Let's think about it though. 3 squared is 9, so I can make that look like an a. I want to see, does it fit into that pattern? Something squared minus something squared. What about this now? So I got something squared minus, well, isn't this really 4x to the power 5 squared? Let's stop and think about that. Because 4x to the power 5, everybody squared, what does that mean? It means 4 squared, and it means x to the 5th squared, it's where I'm multiplying it x to the 10. So yeah, 16x to the 10, I can make it look like 4x to the 5th, everybody squared, so it fits that pattern. There's my a squared minus my b squared. I know the factors are going to be a plus b times a minus b, so it's just going to be 3 plus 4x to the 5th times 3 minus 4x to the 5th, okay? Okay, that is really the extent of the factoring that I think you could ever possibly be hit with for straight up factoring. Now we use that factoring for stuff. You know, factoring is all over algebra. You know, you spend a few hours talking about it, and it's kind of tedious and agonizing sometimes, and then you get done with that factoring section and you kind of breathe a sigh of relief. You think you're done factoring, but then you realize it never goes away because we're using it all the time. Okay, one of the things we use it for is to simplify rational expressions. Okay, now I have a big little production I do in my algebra classes where I identify what a rational expression even is, and I have a lot of fun with it, as you can imagine. It's just a fraction. Okay, and I get some jib-jabs in the class about another fraction. We thought we were done with fractions, but we're not. It's just a big fraction. Okay, something like this. Okay, that's a rational expression, a big looking fraction. Well, we can reduce fractions, right? Well, we can do what's called simplified rational expressions. How do you reduce a fraction? How do you reduce 25 over 30? You factor. You say 5 times 5 is 25, 5 times 6 is 30, and you cancel common factors, and you say, there you go. Let's do that here. What can I factor out of this numerator? I can factor out of 6, can't I? And I'll be left with an x plus 2. What can I factor out of that denominator? I can factor out a 4. And I'll be, not a 4, wait a minute. I can factor out a 7. This one's not very interesting at all. Nothing's even going to cancel. What a dumb example this is. All right, redo. I'm not happy at all with this one. What are they thinking? Oh, I'm looking at an example. They weren't quite simplifying yet, so that's why it was a lame example for simplifying. All right, let's screw that one. Okay, how about this one? 5x plus 35 over 20x. Okay, it's a big fraction. Factor my numerator. Well, the only thing common there is a 5 can be taken out, and I'll have an x plus 7. And down here, my 20, I could call that 5 times 4x, couldn't I, to make the 20x? And then I can cancel those 5's. And have x plus 7 divided by 4x. Okay, that's simplified. Okay, I cannot cancel these x's anymore. Okay, just like I couldn't when I was up here doing 5 times 5. Remember, I think I said in another video, if I had 5 plus 5 over 5 plus 6, I cannot cancel those 5's like I just did. No, because of the plus signs. Well, same thing here. I got a plus sign. I cannot cancel these x's here. Okay, if it were 7 times x over 4 times x, absolutely. Goodbye x's, gone. But it wasn't that. It was 7 plus x over 4x. I cannot do any canceling there. Okay? I have to factor and cancel common factors, and that problem was done. Let's look at this one. What if I have an x cubed plus x cubed plus x squared divided by x plus 1. Okay? And we say, well, what can I factor out of that numerator? Well, I could factor an x squared out of the numerator, and that'll leave me with an x plus 1. And then I had an x plus 1 on the denominator. Okay, and now I'm going to do something that seems like I violated my own little statement here with the plus sign. I'm going to cancel this and cancel that. Okay, and you may be waving the red flag saying, wait a minute, you just said I can't cancel with the plus signs. Here's the difference. Here the plus signs are in between the pieces I attempted to cancel. But here the plus sign is within the pieces I canceled. But outside of the pieces, this right here is times, right? X squared times x plus 1. And then there's, of course, nothing else down here except the x plus 1. So because I have an exact match, and it's strictly a multiplication, I could have something else down here multiplied also, and that would be okay, but it would have to be multiplied. Now I can wipe out that whole piece there, okay? Because it's a multiplication. Alright, let's do one more, and then we're gonna wrap this up. I have to do one that covers the type of factoring that we did. Oh, come on, I don't have one. Alright, bear with me. I'm going to quickly create something here. That's going to be x squared minus 4 there. And that's going to be... Oh, I can't factor that, though. Shoot. We haven't learned how to factor trinomials. Well, you're killing me. I'm killing myself. Yeah, there's just no way to do it, except I could do... Here's what I can do. So I can do... There we go. There we go. Alright, let's do this. Okay, forget about all that. let's simplify that rational expression. So I need to factor the numerator. Difference of two squares, right? That's an a squared minus a b squared. It's going to factor into an a plus b times an a minus b. Okay, so that's going to be an x plus 2 times an x minus 2 on the top. On the bottom, I have a common factor of 3 I can yank out of there, leaving me with an x plus 2. And what do you know? I've got matching x plus 2's. Out they go. I'm left with an x minus 2 on the top divided by 3. Okay? All right, that's a pretty good 20-minute lesson on factoring, and one of the things we use factoring for, which is simplifying rational expressions. Okay, and again, on some of those practice quizzes, a little bit of this topic did show up.